Here we're given the integral cosine x times sine 2x dx evaluated from 0 up to 2 pi. And the first thing that we'll do to crack this one open is we'll rewrite sine 2x, and we can rewrite that as the integral from 0 up to 2 pi times 2 sine x times cosine squared x dx. What we did here is we rewrote sine 2x as 2 sine x cosine x, and then we multiplied this additional cosine x here to make it squared. Now, the next step would be to go ahead and kick this 2 out front. So we've got 2 times the integral from 0 to 2 pi of sine x cosine squared x dx. And now we can perform a fairly straightforward u sub. So we'll let u equal cosine x. The derivative of u in this case is negative sine x dx. And now, since we have limits up here, we can go ahead and transfer those from x into u. So we can say that when x equals 2 pi or 0, u equals, well, evaluating u at cosine of 2 pi is all the way around the unit circle, and at that point the x value is 1. Similarly, at 0, at that same location on the unit circle, u is also 1. And so what our resulting integral really is negative 2 times the integral from 1 to 1 u squared du. And of course this is an integral with identical upper and lower bound limits, which is indicative that our result is 0 because we're evaluating the sum of an area which has no area. Now, just to fully flesh this out and show you what I mean, we can go ahead and work this all the way through. We can say negative 2 times, of course the integral of u squared is u to the third power over 3, and we're going to evaluate that from 1 to 1. And so what we've got really is negative 2 times 1 over 3 minus 1 over 3. Of course that is 0, and 2 times 0 equals 0. So the result of our integral is just 0. If you've got any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.